white dwarfs, you know, as a stellar remnant, pretty much what kind of initial mass will make what kind of white dwarf. Like even within white dwarf, you will have a variety of white dwarfs. So, and with a variety of different elemental richness. And so hopefully that kind of helps. And Chandrasekhar, Subramanian Chandrasekhar gave us the math for that. I find novas and neutron stars fascinating. Oh God, that's what we're talking about. Yay. Novas and neutron stars. Yes, that's exactly what we're talking about. In fact, Reese asked about neutron stars, so I think we'll cover that too. Thank you, Nicholas. According to current estimates, our galaxy, the Milky Way, contains between 100 and 400 billion stars. Also that a killer nova is less bright than a supernova. Oh, well, you mentioned the big stars become black holes when they die. I wondered if there's something denser than black holes that come from even bigger stars. No. So pretty much black holes have a variety. So like a black hole can be, black holes have, they have their own sort of classes, basically, you know. It could be a smaller less massive black hole, a larger black hole, etc., etc. So pretty much what we know is that if a star, if it's a very massive star, the limit was, or sorry, where was it? Stars with initial mass of more than around 18 solar masses or so will leave behind remnants with mass equal to mass max, which is around 3 solar masses for the neutron stars, I believe. So these ultramassive, ultraluminous, short-lived stars will leave behind black holes as their remnants. So pretty much you would make a black hole, and that black hole could have a variety of different masses. And remember that to be a black hole, you basically have to have a certain Schwarzschild radius. So there is a different math for that. We actually covered this a little bit when we talked about general relativity. Remember how Schwarzschild actually solved Einstein's equations exactly for a black hole, what they called a point star. Remember when we talked about Einstein's cosmos from that book we were referencing? And so really it depends on, basically if you have a very supermassive type of star, when that thing collapses, its collapse is a more extreme type of collapse than a more medium-sized star. So when it collapses, it's like, you know, some shit's going down. And it becomes like, it has the tendency, it could become really compact, basically. All of that gravitation is now winning over nuclear power. And so if it goes below the Schwarzschild radius, then it's going to become a black hole. And after that, the black hole can continue to eat more things and become more and more massive. So we can talk about that real quick as well. So the critical radius at which a mass m has an escape speed equal to the speed of light is called the Schwarzschild radius, or Schwarzschild, after the physicist Karl Schwarzschild, who first calculated it in a relativistically correct manner using Einstein's equations. We talked about that a while ago. Any object will become a black hole if you squeeze it until it is smaller than its Schwarzschild radius. So even you could become a black hole.